Hello, now in this video we'll talk about some applications of mathematical induction. Specifically, we'll talk about one proof of divisibility example, one inequality example, and one properties of sequence example. So let's start with the first one. So we have to prove that this expression is divisible by 3 for all positive non-zero integers, for all non-negative integers. Okay, so what we'll do, we'll start with the base step. So base step is what? What is the minimum value of n? N starts with 0. Also n is equal to 0, which means 0 cube. So we will put 0 here, right? So 0 cube minus 7 times 0 plus 3, which is equal to 3, and which is divisible by 3. Okay. Then we will say inductive step. So what is our hypothesis? We will say let k cube minus 7k plus 3 is divisible by 3. Divisible by 3. So we have to prove. So to prove, we'll say k plus 1 cube minus 7 times k plus 1 plus 3 is also divisible by 3. Okay. So we'll start with this expression. So we'll start with this guy. So if I expand it, this becomes k cube plus 3k squared plus 3k plus 1. This becomes minus 7k minus 1 plus 3. Correct? Now if I rearrange, I'll rearrange this guy, and this guy. So I'll say k cube minus 7k plus 3 plus 3k squared plus 3k, and then I have this one, this minus 7, right? Mistake here. Okay, so this is plus 1 and this is minus 7, so this becomes minus 6. Okay, now this guy is divisible by 3. This guy is divisible by 3 because 3 is this 3 times something. This guy is also divisible by 3 because this is 3 times something, and this guy is also divisible by 3. So this means we have sum and difference of all terms divisible by 3. So this means this whole thing is divisible by 3. Okay, so this is how all we did was just open this expression, and then just rearrange some terms and used our inductive hypothesis to see that this is actually divisible by 3. So this means that we have proved that whenever we have n cube minus 7n plus 3 for all non-negative integers, that expression is always divisible by 3. Okay, now let's move on to inequalities now. Okay, now we have to see, so this is 5 to the n plus 9 is less than 6 to the n for n is greater than or equal to 2. So our base step will be n is equal to 2. So then we will check 5 to the 2 plus 9 is less than 6 to the 2 or not. So 5 to the 2 plus 9 is 34. 34 is less than 36. So this is base step is now fulfilled. Now we'll say inductive step. We'll say let 5 to the k plus 9 is less than 6 to the k. And we have to prove what? We have to prove 5 to the k plus 1 plus 9 is less than 6 to the k plus 1. Correct. Okay. Now what we do, we'll start with left hand side. We'll start with, we'll say 5 to the k plus 1 plus 9. So this is equal to 5 to the k times 5 plus 9. Now our hypothesis, I can write it as 5 to the k is less than 6 to the k minus 9. I can do it, right? So then I can replace this guy and say less than 6 to the k minus 9 times 5 plus 9, which is equal to 5 times 6 to the k minus 45 plus 9, which is equal to, say, 5 times 6 to the k minus 36. Okay, so now I can replace this 5 by 6 and put another 6 less than sign. So I can say 6 to the 6 times 6 to the k minus 36. So I can say less than 6 to the k
This should be
plus
equal
1
to
minus 36. So this is less than 6 to the k plus 1, correct? So because I'm subtracting 36 from this, right? So if this guy is 36 less than this guy. Okay, so then we started with this one, so we'll say is equal to right hand side. By right hand side I mean this guy. Okay, so then we have proved it. All we have to do is we have to use some inequalities. We have to use the inductive hypothesis and then use some inequalities along the way. So one inequality I used was 5 is less than 6. Then another inequality I used was that 5 to the k is less than 6 to the 9, 6 to the k minus 9 because of inductive hypothesis. Okay, okay. So this is about the inequalities. Now let's move on to sequences. Now we have a sequence b0, b1 and so on, and it is given by this relationship. We have initial value is 5 and the next value is 4 plus that number. So actually we have the sequence like this: 5, 9, 30 and so on. So everything is 4 more than the previous one. Every term is 4 more than the previous one. What we have to show is, we have to show that, and this is your b0, this is your b1 and so on. We have to show that b of n, because the square of that number is greater than 16 to the n squared. Okay, so again, what is base step? B of 0 squared greater than 16 times 0 squared. So this is obvious because this is 5 squared, this is greater than or equal to 0, so this is true. So what is inductive step? So for inductive step, what we do is we say let bk squared is greater than 16k squared. Okay, and then we have to prove that bk plus 1 squared is greater than 16 times k plus 1 squared. Okay, now before we start the proof, now note that all our terms are positive numbers. So this means I can take the square root of both of them and make a inequality like bk is greater than 4k. Okay, so we will have to use this part as well in the proof. Okay, now let's start with bk plus 1. So bk plus 1 squared, this is equal to 4 plus bk squared. Okay, so if you open this, we can get 16 plus bk squared plus 8bk. Okay, now this guy is greater than 16k squared because of inductive hypothesis, and this guy is greater than 4k, correct, because of this guy. So we can say this whole thing is greater than 16 plus 16k squared plus 32k, right? Now if I remove this 32k, I can no, I don't have to remove this 20. So I can say 16, I can say k squared plus 2k plus 1. So I can say is equal to 16 times k plus 1 squared is equal to right hand side. So we started with the left hand side here, and we said this is equal to, this is equal to, this was greater than equal to, and then we have a couple of other equal to's here. So this means we can say left hand side is greater than equal to right hand side. Okay, so this is the proof for sequences. So now we have seen that mathematical induction can be used for many purposes. We can prove the divisibility problems. We can prove whether an expression is divisible by some specific integer or not. We can also prove some inequalities. We also can prove some properties of sequences by using mathematical inductions. So hope it was easy to understand. Thanks for watching the video.